Okay, in this lesson we're going to be looking at geometric sequences. Previously we looked at arithmetic sequences and series. Today we're going to be talking about a different kind of sequence called a geometric sequence. You know, yesterday or the other day we talked about arithmetic sequences where there's a common difference. And we had a way of writing rules for arithmetic sequences. We also found a way of adding up the numbers in a series. Arithmetic series had this formula. Today we're going to talk about rules for geometric series or sequences, something like this. So here's a problem. Say, let's look at how things go viral. 10 people watch a YouTube video, they like it and share it with 5 friends, each of them. So 10 times 5 gives 50 friends, they like it, and then they tell their 5 friends. So then there's 250 friends who then watch it, and so on and so on. How many iterations will it take before it hits 10 million views? So the sequence would go like this. We start off with 10 people. Each one of them tells their 5 friends, and then 50 people view it after that, and so on, 250, and then 1250, and so on. Now, you could see that this is not an arithmetic sequence. Plus 40, plus 200, plus 1,000. No common difference, but we do have a common ratio here. We're multiplying times 5 each time here, so we call that a geometric sequence when the ratio of any term to its previous term is constant. And in this particular case, this geometric sequence has a common ratio of 5, where we use r to be this common ratio. So remember, with arithmetic sequences we use this variable called d. D would be the common difference. In this case, r for geometric series is the common ratio. So you can practice and check to see if these are arithmetic sequences, geometric sequences, or maybe none of the above. So let's try to derive a general formula for the geometric sequence. So let's look at this specific example, and let's look at the first term. The first term is 10. Second term is 10 times 5. I'm going to break it down. Instead of writing it, instead of thinking of it as 50, I'm going to think of it as 10 times 5, because these 10 people told 5 people each, so they told 50 people in total. Then those 50 people told 5 people each, and then those 250 people told another 5 people each. So when we write it like this, it exposes kind of maybe some underlying information, which allows us to rewrite it as 10 times 5 to the 0, 10 times 5 to the first, 5 to the second, 5 to the third. So now we see this pattern emerge, which allows us to write a general case. The nth term of this sequence would be equal to, we see this common 10 here, okay, and then we see this common ratio of 5 raised to the power of n minus 1, because we see here that when the term is 4, the exponent is 3. When the term is 3, the exponent is 2. It's 1 less than the term number. So we could see a general rule being formed for any geometric sequence where the nth term is the first term times the common ratio times n minus 1. And so we see it kind of play out in this specific case here, where A1, the first term, was 10. We had our common ratio here being 5. So 5 is the common ratio. And then we had n minus 1 here, raising it to the n minus 1 power. Let's contrast that for a second with the arithmetic sequence rule. And it's kind of informative because we see that there's this commonality. There's the first term, which starts it off. And then instead of, with arithmetic sequence, we added d times n minus 1. Instead of addition, we're multiplying. Instead of multiplying here, we're raising to the power. So I think that that's kind of a interesting kind of, so the addition turns into multiplication. The multiplication here turns into exponentiation. So again, you could practice on these problems below. Let's move on. Here's a case where we're given two values of a sequence. The third term is negative 48. The sixth term is 3072. We're told that it's a geometric sequence. Let's see how we could figure out the rule for this. Now remember, we want to get to this. AN is equal to A1 times R to the n minus 1. We're only given this information. We know neither the R value, we don't know the common ratio, neither do we know the first term. We're given the third term, we're given the sixth term, we're not given the first term. So what we're going to do is generate two equations so that we can solve for two unknowns. Now we are given the value of A3. A3 is negative 48. So let's use this kind of equation here and use this over here. So we don't know A1, we don't know R, but we do know that this is the third term. So we're going to put 3 minus 1 as the exponent up here. Okay, so that's one equation. Equation number 1. Let's look at equation number 2. We're going to take A6, we know that's 3072, and again we don't know A1, we don't know R, but we do know that this is the sixth term, so we're going to put 6 minus 1 right there, and this is our second equation. Now we're going to combine these in a clever way such that we remove one of the variables. So the secret here, and I just simplified this over here, A1 R squared, A1 R to the fifth. The secret here is we're going to divide A6, we're going to divide equation 2 by equation 1. So this is what I mean by that. We're taking everything in yellow here, the 3072, the A R to the fifth, A1 R to the fifth, and we're going to divide that by the green here, the negative 48, the A1 R squared. And the cool thing here is when we divide these two equations, the A1 divided by A1 cancel out, they reduce to 1, and so it gets rid of that variable, and we're left with the variable R, which we can then simplify to R cubed. So now we have R cubed is equal to negative 64, that's dividing these two numbers. We take the cube root of each side, we get R is equal to negative 4. So we found one variable, we're not done. We want to get to this. We need to still find A1. So let's plug R into one of the equations. So I'm going to choose to use equation 1 and plug this value of negative 4 into this equation here. So I get negative 48 is equal to A1 times negative 4 to the second power. That's again from this equation right up here in green. Okay, so from there. So then we solve for A. We find A to be negative 3. And now that we have all that information, we can go and combine that all together into our general equation. Again, using this as the form, we just plug in the values that we just discovered into that. Okay, so you can practice on this next problem, and that's the lesson for today.